Hi guys, welcome back to another video. So in this video, I have something special for you guys. So last time we made a COVID-19 app, but this time I'm gonna, sort of dig into the health, or should I say the medicine field, I guess. And we're going to be looking at diabetes. And I thought of helping this, field by making some machine learning models and then deploying them to the web. So to help this field, I made a simple diabetes predictor. Of course, this is not 100% the best, but it does a decent job. And I want to show you how I made it, and let's see how it works. So first, we're gonna be talking about the theory, the thing behind the app, but we're not gonna go to the practical yet. Once I'm done talking about the theory of this app, how this app works in theory, I'll get into the code and all that other stuff. So to begin with, I'm going to discuss about the libraries that I have used. So for the machine learning part, the ML algorithms and some pre-processing stuff, I used scikit-learn like always. Inside the scikit-learn, I used the random forest algorithm. It's a great algorithm, and I'm going to show you guys the code of how I imported it and how I trained the model once I get into the practical part. And so that's what I used for model building and training and stuff. I also used NumPy and Pandas for the pre-processing part of this app. Creating data frames and manipulating data and stuff. And I also, to deploy the app to the web, as you can see on the screen right there, I used a library called Streamlit. Streamlit is a great library for website building, but it's more focused on the data part. So, if I were to compare this to other website building, sort of applications or frameworks like Django or Flask. Django and Flask, you use those for more general stuff. But Streamlit, you can't do those stuff with it, but you can build apps that involve data and machine learning and AI and that field. So it's more used by data scientists from all over the world for a model deployment to the web. So I love this I love Streamlit because it's very easy to use and it makes me more productive, and I can get into it hands-on with just 2 clicks. So that's why I like Streamlit, and its widgets, its components are very beautiful and it's very well organized, so you don't have to worry about placing them at certain different points. And that really takes lots of time away from it, which makes me very productive using this framework. So that's the libraries that I used, and now I'm gonna I'm gonna tell you guys how my process, how I first got the data, where I got the data, how did I build the model, how did I train the model, and how I deployed it to the web, and then I'll get into the practical part. So to begin with, I found this data on Kaggle. This was this one. So Pima Indians diabetes dataset. I will show you guys it in the practical part, the actual coding part. So it's a great data set, and like always, all data sets have their limitations, and so that this data's limitations was that it was only targeted for women and girls, to be precise. So I was looking for a data set that could have a separate value for not separate value, independent variable for gender, but that wasn't the thing, and there were 2 separate data sets, and I had to sort of merge them, but I didn't want to do it because I didn't find a diabetes data set for males. So number one, I could have just gathered them, but that would take too much time, so I just went for the one that I had, the one that was more easy to get. And then after getting the data, I did some pre-processing. I got my dependent variables, and there were some zeros, and I can't have zeros. the machine learning algorithm random forest, it won't accept zeros. So I have to find a way to fill it in. I could have used the median mean mode, but I decided to go with the average or median mean. So I filled all the zeros with the mean or average, and after I did that, I went straight to the model building part. But before I go into the model building part, I split the data set into a test and training, like data. So I had 30% training data, no, 30% testing data, I'm sorry, and 70% training data. And it went good. And then I trained my random forest model, and then I saw that the accuracies were low. It did a decent job. It had 71% accuracy. It wasn't bad, but I wanted to increase it anyway. So this is where I went to hyperparameter optimization. So watch my video on hyperparameter optimization and you will know what I'm talking about. I'll put the link in the description so you can check that out. So I'm not using grid search, but there's another technique called random search. It's more powerful and it's more flexible to use than grid search. So I used the random search algorithm or whatever. So I applied it. So I gave it a sort of dictionary, and those dictionary contains like other variables that uses anonymous functions and stuff to loop over some numbers. And I created the dictionary, and I put the dictionary inside the the actual random search algorithm, and it gave me the best hyperparameters. And I put these best hyperparameters to my actual model, and I got even better scores. I had 74, 75, and 76%. It would go, at 74, and then it would go up to 76, and then the next time it would go to 75. But it did okay. At least it was in between 74 and 76, and that was good for me. So after that, after I improved the model's performance, I went to the deploying part to the web. So I used this framework called Streamlit, as you may know, and I used some of its components to design the web page itself. And after I did that, I made a certain function that calls these sliders, the user input parameters. These are the parameters that these are basically the independent variables. Basically, the person who's trying to find if they have diabetes or not, they change the values, and the machine learning model then predicts if that person who changed the values and set their value at a certain scale, the machine learning model just predicts if that person has diabetes or not. It's as simple as that. So I made that sliding thing, and then I converted the numbers that were there that the person fixed into a pandas data frame that could easily be trained or fitted or whatever to my random forest model. So I did that, and the results were good. The text would change to this person has diabetes to this person does not have diabetes. So it would change depending on the values that you fix. So that's how this app works. So now let's get into the practical part, the code itself. So yeah, let's get into it. So this is the code of this app. So yeah, it's about 101 lines. I commented out some of the things here. And yeah, this is the thing. This is the code. So let me just go to the data here. So this is the data, the Pima Indians diabetes database, sorry. So here are some, oops. So we can't open it. That's weird. But it has some information about this data set and some other stuff. So it's only for females, of course. So we go back, and So this is the Streamlit. So I run the Streamlit, the code using the Streamlit framework. So I did Streamlit run main.py in this directory. So yeah, that directory. Oops. And it just opened up. It will open up my web browser, and here's the app. So let me just show you this app for a second. So there are some user input parameters on the left side. And if I can adjust these user input parameters, and based on these parameters, this thing will change. Yeah, so this thing will change to this person has diabetes. So let me just do some random things like this, this, and this. So this will change to this person does not have diabetes. Well, it depends based on the model. So this is what the model thinks. This is what the AI thinks. So this is not what I think, but you get the point. So if I do this and do this and do this, it will change maybe. Let's see. Yeah, so it changes to this person has diabetes. So it really depends on the value that you put in. And oh, this table here, this table shows you what are the values you have entered on the right of the left side. So so you can see the things that you have written, and that's weird. Age is 46. Maybe the 0.61 is just the the months or something. Maybe I don't know. But so that's that, and that's how the app works. Now I'm gonna tell you guys. I'm gonna walk you through the code, and I'm gonna show you guys how this app works. Um, this this. Let me just do that. Oops. Okay, that's weird. Yeah, okay, that's weird. I'm just gonna full screen this. Okay, so I'm gonna show you how this app works. So here are some libraries that I have imported: Pandas SPD, NumPy SNP, and Streamlit SSD. So I bring in ST, and then there's a separate thing. There's a function, a method called write. Using this method, I write the sort of header, simple diabetes app. This app predicts if a person has diabetes or not. So this thing, so this the this just means how bold the the word is basically. So if I add an extra asterisk or whatever, and if I save this, oops, you see that always rerun. This thing is extra italic and extra bold, I guess. So that's what this asterisk stands for. Just one of that. And now it's gonna rerun, so it's running. So yeah, boom. Um, so that's that. And st.sidebar.header. So the sidebar is just the thing on the left, this part, basically. So this sidebar, and the sidebar.header, the header of the sidebar is the user input parameters, and that's what we have specified over here. Line 10. So what this is basically the this part, the slider part. So what we do is we simply create some variables this with the sidebar.slider. So this is a separate component, I guess, inside the Streamlit framework, and I specify some values inside of this slider component or method or whatever, and I specify the name numpreg. I think this stands for like number of like pregnancies for girls. And these three numbers. So the first number is just the minimum, the 10 is just the maximum, and the 1 is just the number that's default. It's already there. And this one, glucose, is the like it's supposed to be glucose, but I don't know why it's there. So this one is glucose, and this is the minimum number, the maximum number, and the default number that's already there. And this is a diastolic blood pressure. I don't know how to pronounce that, so correct me if I'm wrong. And this is the minimum number, the maximum number, and the number that's already there for you, or the default, and some other values over there, and like the body mass index, like BMI or whatever, the diabetes pedigree function, and the age of the person. So here's the data basically, and here I using that variable, I create the pandas data frame. So features equal to pd.dataframe, the data index is equal to 0. So I just created pandas data frame with all of these values. No, actually all of these values, right? And here I just df, and then it's gonna return the features. So I create a variable, and then I put the function inside that. So when I write call this, it's gonna return the features basically. So st.subheader and user input parameters, this part, and here st.write df, it's just gonna print out the values that you have entered on the sidebar. And now we just get into the machine learning part. So this data, so we create a variable called data, and then we read CSV, all that. We read the data set, and here, I'm just gonna get into that data set and do this. So as you can see, the last column, which is diabetes, it has true and false. You can't have letters, so I would have to convert them into numbers. So for true, where is it? True, I bring in 1. For false, I bring in 0, and then we just put that in. And here I train test split. I what do you call it? I imported that library, and here I specify my independent dependent variable. So the predicted class, or the dependent variable, or target variable, whatever you call it, is diabetes, and the independent variable is the feature columns, which is the rest of the columns basically. Oops. Right. Yeah. So x is equal to data feature columns dot values, and we're just bringing in these things into x and y. So it's much more easier to do stuff. And here we split the data set, the entire data set, into a x train, x test, and y train, y test. So the test size would be equal to 0.30, which is 30% of the entire data set, and which means that the training data, it would be 70%. And we just fix the random state. And here, the imputer, so what we do here is, there are some zeros. There's one over here, one over here, one over here. There's just a lot of zeros, and we don't want that. So we use this imputer to replace these, zeros with the mean of that entire, independent variable. So, that's what we do here. Basically, missing values is equal to np.nan, and strategy is mean. I can change the mean to median or mode or whatever, but I'm just gonna go with mean for now. And then we transform it using the imputer that we have created. And here we go to the model building, and the and training part basically. So I import the random forest classifier from the sk.ensemble, and here I call in the random forest classifier, and then I put that into the random forest model variable, and here I just specify some parameters, but these are not the finalized parameters. And let me show you. And then here I train it and stuff, and I can show you guys the accuracy of this random forest model I'll show you guys the accuracy for that, but it was somewhere around 71 and 72%. So that's the accuracy of this model. But since I wanted to improve it, I used randomized search, random search to shorten that. And here I just I just loop through the numbers and max features, and then I fix that. And these variables are just created into a dictionary, as you can see over here. And these are just the parameters. Um, and then with the random forest, not that random forest, then I just come on, what do you call it? I use a randomized search to see the best parameters. So that's this piece of code. That's 84. So I get my parameters and then I put it to the RF random forest, and that's this one. And if I predict the values of the newly created one, it's much better. So let me show you guys here. So this was the old accuracy, 7.2, like I told you guys, but then this was the new accuracy. So it had some drastic improvements. Not a lot, but I mean at least some. So after we do that, I predict its accuracies, and we see that it does a good job, a decent job to be honest. And then what we do is we create another variable called app prediction. This app prediction is for this one. So then we use the newly created model with the hyperparameter optimization, and we use that model to predict the data frame, which is this one, which is just this part or this part, the pandas data frame that we create with this dictionary, right? So let me go back, and so if appred prediction is equal to 0, then we simply write st.write this person does not have diabetes. So if app prediction is equal to 1, then this person has diabetes. So since I could have just gone for like a simple logistic regression, but I didn't want to. So I just went for the random forest. Maybe in the future I'll update this so it has a XGBoost instead of a random forest. It will surely have much more higher accuracies, but this is good for now, and there you go. That's the entire coding thing. Yeah. So make sure to subscribe, like, and comment as always. And yeah, see you guys.